Hello everybody, so I'm Christian Fabre from CEA. I will present the work mostly done by César Fuguet, my colleague, which basically introduced this technology last year to the OpenRWA group, and I will give an update about the job which has been done the last 12 months or so. So it's about high performance out of order level 1 data cache, HPD cache. So we'll first start with the motivation for this work. So it's basically in the HPC world, there is the bottleneck is really the memory, so that's a problem which is not new, but it's getting more acute as time goes by. New technology like HBM, for instance, make it worse. Going to chiplets makes the problem worse. So what you need something which has some multiple in-flight requests to efficiently use your memory and bring data back to the processor and to have the highest bandwidth you can get. So when we started this work, when we pushed that to the OpenRWA group, to our knowledge there were no data cache, level 1 data cache, which were dedicated to HPC. Okay, so this is a block diagram, what it looks like. So you can have several input which send requests. So basically it could be several processors, or it could be several data paths within a processor. In our case, we have two data paths coming down, one for the regular, for variable precision floating point. We've got the regular data path going down, and we've got the floating point data path going down. There is also included into that RWA memory prefetcher engines for stride access for matrix computation. So it had all the good properties of a cache, support for standard load, store, atomic operation and all that, pipeline microarchitecture, out of order execution for memory accesses, for memory operation, programmable hardware, etc. So that's basically the current status. So there's a number of prototype being worked on. Some of the work were done through the European project EPI, European Processor Initiative. So there is some silicon which got back from factory in spring. The bring up has been done, and we're working on that. So the characteristic of those one are described here. So you've got 32 kbytes of capacity, 64 byte cache lines, 128 in-flight misses, 4 hardware memory prefetcher engine, and 60 page requests for the load store unit. We work also to provide that to the OpenRWA group, put some strong emphasis on industrial grade verification. So there is a DA request agent, a configuration agent, memory response model, scoreboard, and there is quite a large coverage, code coverage through this test bench. So what is it used for and how could it be used? So for instance, in matrix computation, you've got several blocks. You divide your matrix on several blocks and of the same size, and basically there is a way to parameterize the hardware prefetcher with the size of the block and the stride and all that. And there is the computing loop where you compute the proper address to prefetch the next block, and then you do the computation of the previous block that you've just loaded. The hardware prefetcher plus the cache provide quite a gain in performance. So if you don't have the hardware prefetcher compared to when you have, if you have the hardware prefetcher, you've got 33% improvement in terms of performances on the matrix vector multiplications. So this is heavily used, that goes without saying, into linear algebra. This has been financed through several projects: the EPI project, which is still ongoing, and the Tristan project, which is started a year ago or so, and will go forward. And I will go through the current work, which is the latest development. So the work which has been done this year up to now, so it's been released in February through the OpenRWA group on their website. It has been integrated with CVS6 to the point where now when you instantiate CVS6, you can pick one of the three hardware level 1 cache, and the HPD cache is one of them that you can pick. We've added the support for virtually indexed, physically tagged addressing late August. And the Linux is booting on the FPGA using CVS6 plus HPD cache, so that's something which I've done in August, so it's working, it's proved and it works. There have been some other initiatives trying to improve or to make some work in progress or to exploit that. One is with OpenPython, CVSIC and HPDCache. So that's part of the Google Summer of Code. It's a joint project between BSc and Politecnico Catalonia, UCSB and CEA. So Linux is booting as of last week. So actually a week ago tomorrow, it's actually booked on an emulator, on the large emulator that we have on Siemens Veloce Strato. And leading European Research Institute have been integrating the HPDCache with their own out-of-order core. The highlight for 2023, so the work in progress, this will be part of the Tristan project. So we'll introduce a hybrid write-back, write-through policy, which will be on per cache line basis, and a scratchpad mode. So if you've got some data that you want to use very heavily, you can put in a scratchpad mode completely a full bank of the cache. That means it will have a fixed address and your data will be quickly accessible into that. So that's the highlight that the stuff we are working on at the moment, and it will be already on track for mid next year basically. Thanks.